This is shuttle launch control at T-minus 3 hours and holding. Standing by now to receive video from the astronaut quarters of the STS-83 crew suiting up. And here we are. Here we see our commander, Jim Halsell. And Jim Halsell was phoned previously on STS-65 and STS-74. And he's logged a total of about 23 days in space. Here's our pilot, Susan Still. Second female pilot to fly the space shuttle. Graduate of Embry-Riddle Aeronautical University locally in Daytona Beach. And also a graduate of Georgia Tech. Janice Voss, our payload commander on this mission. She's logged more than 18 days in space. This is her third space shuttle flight, having flown STS-57 and STS-63. And mission specialist number 3, or rather payload specialist number 1, I'm sorry, Roger Crouch, will be responsible for much of the science operations on board the Microgravity Space Lab. This is his first space shuttle flight. Mike Gernhardt, mission specialist number 2, and also our flight engineer for STS-83. He's flown previously on STS-69, and he has more than 10 days in space, so this will be his second shuttle mission coming up. And he has a PhD from the University of Pennsylvania. This is Greg Linteris. Tom Linteris, our payload specialist, number 2. And Don Thomas, mission specialist. Mission specialist number 3. Here's Greg Linteris. Payload specialist number 2, his first flight into space, also responsible for much of the science on board the Microgravity Science Laboratory. Here's Don Thomas, once again, mission specialist number 3. And Susan Still about to be assisted with putting on her helmet. The crew will be leaving for the launch pad in about another half hour. And Space Shuttle Columbia, as we see it there on the launch pad, weighing 4,523,854 pounds. Orbiter Columbia itself is just under 190,000 pounds, or just 4% of the total launch vehicle weight at liftoff. We have about 8 minutes remaining in this built-in hold, and all our countdown activities proceeding on schedule for a launch at 2 o'clock this afternoon. At T-minus 3 hours and holding, this is Shuttle Launch Control. This is shuttle launch control at T-minus 3 hours and holding, with about 2.5 minutes remaining in this planned 2-hour built-in hold. Earlier this morning, the STS-83 crew members went to the dining room of the astronaut quarters for breakfast. We'll look at some videotape of that activity. And all 7 crew members and the traditional cake with the emblem for STS-83. Down on the far end is payload specialist Greg Linteris, and next to him is mission specialist number 3, Don Thomas. Our pilot for STS-83, Susan Still. The commander, Jim Halsell. Mike Gernhardt, mission specialist number 2, and our flight engineer, Janice Voss, mission specialist number 1, and the payload commander. And next to her is Roger Crouch, payload specialist number 1. Some of the crew has been up since as early as 3:30 this morning. Others were awakened around 9 o'clock. This is because they're staggered sleep cycle on the mission, since they will be up doing experiments on board the Microgravity Science Laboratory 24 hours a day. And there's the cake, and after breakfast or a snack, then they all went for the weather briefing and then into the suit-up room for suit-up, which we just saw, and they should be leaving the astronaut quarters in about another 5 minutes or so. Sunlight shining brightly into firing room 1 here at the Launch Control Center at KSC, where all of the members of the launch team have been on station, most of them since fueling began at a little after 6 this morning. And here we see pad 39A at the edge of the Atlantic Ocean. We're standing by now to come out of this 2-hour built-in hold in just a few moments. Coming out in 4, 3, 2, 1. We're now at T-minus 3 hours and counting. This is shuttle launch control at T-minus 2 hours, 58 minutes, 30 seconds and counting. And we see the STS-83 crew has just left the suit-up room, headed for the elevator. Be heading down from the 3rd floor to the 1st floor, aboard the astronaut van, for the 20-minute ride out to pad 39A. Meanwhile, out at the launch pad, the final inspection team has just reported that their activities are complete and they're leaving the pad. And in just a moment, we should see the crew Many KSC employees and well-wishers waiting to greet them as they come out of the elevator. And here they come. Larger than usual contingent of employees wishing them well. And they will begin boarding Columbia at about 11:15 in about another half hour. And there they go. And we should be able to follow their progress out to the pad once they come within range of the TV cameras on the roof of the vehicle assembly building as they head down Saturn Causeway. Among the activities since the countdown clock began counting backward at 2 p.m. on Monday, a review of the software stored in Columbia's flight computers and a loading of the backup software, stowage of the items that the astronauts will use on orbit into the mid-deck lockers, and a removal of platforms between the mid-deck and the flight deck. On Tuesday, the work to load the fuel cell cryogenic reactants began. That was suspended, however, to allow the wrapping of insulation around the cooling system lines in the payload bay, which was deemed necessary, so that activity was then completed early Wednesday morning. After that work was finished, the orbiter's communication systems were turned on and checked out. The navigation systems and landing aids were turned on and tested. The guidance system inertial measurement units were warmed up and checked out. The Star Tracker navigation system was tested, and the main engine controllers, which are the computers associated with the main engines, were loaded with software. Also, the sound suppression water system tank was filled with its 300,000 gallons of water. Last night, the switches were configured in the cockpit for launch, and shortly after 8 o'clock, the gantry light rotating service structure, which provides the primary access and weather protection for the shuttle, was retracted. And overnight, the orbiter's fuel cells were activated. Since that time, all of our activities have continued on schedule. So the crew should be arriving at the launch pad at about 11:05. At T-minus 2 hours, 53 minutes, 24 seconds, and counting, this is shuttle launch control. This is shuttle launch control at T-minus 2 hours, 50 minutes and counting. Most of our communications channels here in Firing Room 1 are quiet because we are not working any problems in the countdown, and we are still anticipating an on-time liftoff at 2 o'clock this afternoon. Look now briefly at some video of Space Shuttle Columbia being prepared for its upcoming launch. Here we see the orbiter being backed out of OPF Bay 1, the Orbiter Processing Facility, on March the 5th, atop the orbiter transporter for the brief 20-minute rollover to the transfer aisle at the Vehicle Assembly Building, at which point the lifting sling was attached so that Columbia could be rotated to vertical. And there's the lifting sling in the background. And here we see Columbia in the vertical position for mating to the external tank and the solid rocket booster stack. After the mating was complete, that was followed by the shuttle interface test to verify all of the electrical mechanical connections, and then the rollout about a week later on March the 11th for the 3.5-mile trip out to Launch Pad 39A. The crawler transporter moving along at about 1 mile per hour. And the trip taking about 6 hours from first motion until hard down on the mobile launcher platform. And after Columbia was in place atop the launch pad, the connections were made to the fixed service structure. And that was then followed by the terminal countdown demonstration test. Here we see the astronaut van by the Launch Control Center awaiting clearance to proceed to the launch pad. There's the east side of the Vehicle Assembly Building on Complex 39, with the Launch Control Center extending outward from it to the southeast. And now they're moving ahead out to the launch pad. And while they were stopped there at the roadblock, astronaut Ken Cockrell left the astronaut van to go to the shuttle landing facility to begin flying weather reconnaissance and approaches in the shuttle training aircraft. He'll be passing his weather observations to Blaine Hammond here in Firing Room 1. And at T-minus 2 hours, 45 minutes and counting, this is shuttle launch control. This is shuttle launch control at T-minus 2 hours, 37 minutes, 30 seconds and counting. The astronauts have arrived at the 195-foot level of the fixed service structure where the orbiter access arm is located. And the commander and pilot will walk across the arm shortly to begin their boarding, while the other crew members await their turn out on the arm or on the fixed service structure. And as we've been able to tell, they're thoroughly enjoying the very nice day out at the pad to take advantage of looking at Space Shuttle Columbia being prepared in the last hours here for flight. Shuttle Test Director John Guidi has just polled all of the key members of the launch team here in the firing room to verify that there are no launch criteria violations on any of the systems, and all of those system team members report no violations and they are go. So as we await now the astronauts to board Columbia at T-minus 2 hours, 36 minutes, 10 seconds and counting, this is shuttle launch control. This is shuttle launch control at T-minus 2 hours, 34 minutes and counting, where we see Commander Jim Halsell being assisted with his equipment for entry into Space Shuttle Columbia. He has already spent 23 days in space, having flown previously on STS-65 and STS-74. One of the most beneficial and popular programs while the Space Shuttle is in orbit involves amateur radio communications and the SAREX program. Mission Commander Jim Halsell was asked, what is SAREX?
SAREX is the shuttle amateur radio experiment. It's another one that's been with the shuttle program for a number of years because it has been, once again, so successful. And what we do with SAREX is, over the course of our 16-day flight, we are talking to approximately 16 different schools around the world. Several in the United States, my home state of Louisiana, I'll get to do one there. California, my pilot, Susan Still, will do one to her home state of Georgia. We have a number of different schools in Europe, and also I think for the first time in the history of the shuttle program, we're going to do a contact with China, with a university in China. It's getting tremendous response there. I understand it'll be broadcast on their television system, and they expect 100 million viewers to tune in for this 5 to 6 minute contact between us in orbit and the students at the university there in China. So the opportunity to spread the word about not only what we're doing on STS-83 and what the Space Shuttle program is all about, but also what the United States is all about, and to better our connections, our goodwill with people around the world. That's what SAREX is all about, and it's been tremendously successful. And actually, when you get up there and get all the antennas set up, it's a fun thing for the astronauts to do, too. It gives you an opportunity to talk to students and answer all the questions. And in that short 5 to 6 minute period, because we do try to answer the questions quickly and get as many students across the microphone as possible, you have a real sense that people are watching you and they care about what you're doing. They're excited about the project, the space program, and what your involvement in it, and it just lends something to the whole spaceflight experience.
This is shuttle launch control at T-minus 2 hours, 28 minutes, 57 seconds and counting. And in the white room, we see Payload Specialist number 2, Greg Linteris. He will be working inside the Microgravity Science Laboratory Space Lab and is responsible for much of the science activity. One of the important questions to be answered on this mission deals with the quality of the microgravity environment, which is so important to the kind of research on the space shuttle on the International Space Station. Greg Linteris was asked about the importance of the measurements which are going to be made on STS-83.
Well, it turns out that when you're in the orbiter, you don't have zero G. We have some residual level of force that is exerted on the experiments, from thruster firings to the orbiter's position, from crew activities, closing lockers, moving about. All these things create forces. For one action, there's an equal and opposite reaction, as we know from Newton. So understanding if the important parameter in the experiments is microgravity, very low levels of force exerted on these growing crystals or burning flames, then we need to know just how low they are. And so we have numerous instruments throughout the module and in some cases right on the experiments that measure very accurately the levels of acceleration that are experienced during the flight, so that we can understand how the amount of acceleration right during an experiment might have affected the result that we saw. Of course, these things are all time-tagged. We'll be able to compare them. Also, we'll be able to correlate our activities, our exercise period or our eating periods or sleeping periods, with the acceleration levels, and we'll be able to understand how those activities on the space station, for example, would affect the microgravity levels that will be experienced. So it all fits together in a way that gives us information on the important parameter that we're trying to minimize during the flight.
Here's GNC, step 500 does not perform, and we'll get ready to pick up with step 501. I copy, you can do it for the clock. Copy. I'll give you a 502 for the clock also. Copy. And OVCC, did we have a mission specialist go on?
Confirm he's going ahead at this time.
MS, what?
That's PS2.
PS2, I copy. QC will call it 1614 GMT.
Pilot Susan Still now being assisted with her equipment. She'll be in the right seat of Columbia. Susan still has responsibility on this mission, which runs the range of extremes. As the pilot, she'll have the significant responsibility for the safety of Columbia and the other astronauts during launch and landing, along with the commander. However, during the mission itself, she'll also help out the other crew members with the day-to-day domestic details of daily living while in space. Susan Still was asked to describe her range of responsibilities for the mission.
Well, the most dynamic phases of the flight are really where I get involved. During ascent, all the engine and hydraulic and electrical switches are on my side of the shuttle, and so if there was to be a malfunction with one of these systems, it would be my responsibility to handle the emergency procedure and make sure that the orbiter stays safe. During entry, I back up the commander. I will make airspeed and altitude calls, lower the land gear, and deploy the drag chute. And if something was to happen to the commander or his side of the shuttle, then I am prepared to land the shuttle itself. During the other 14 and a half days we're in orbit, the majority of my job will be monitoring and maintaining the shuttle. There are certain maintenance items that need to be done every day, cleaning the waste system, keeping control of the trash, making meals for the scientists that are working in the laboratory. I mean, all those things have to be done, and it'll be my job to do them.
Susan Still will be in the right front seat. Gregory, who just boarded, is sitting in the middeck right seat.
OTC GMC, go. Yeah, we're through, complete through 507, we'll give you 508. Ready for GMT Delta adjust. I copy, let me just notify NTD. GPS OTC, step 510. You ever go on GMT MAT adjust?
Copy, I'll need a sync 2C on 12, and if you notify LPS to OIS, that will go no-go.
LPS 2 copy. QC 152, please.
Copy.
OTC, ODCC. Go. PLT entering at this time. Copy. CMQ, that's scene 18 GMT for 499 PLT. Copy. COSC, OTC. COSC. I'll be standing by for 515. Cap.
Mission Specialist number 2, Don Thomas, is next aboard.
OTC, COSC. Go. I can give you a 515. We're ready for post-ingress switch reconfiguration.
Copy.
Don Thomas, who along with Janice Voss will be involved with much of the operation of the Space Lab module on this mission, was asked the question that after he returns to Earth, how does he think this flight will be viewed in the overall Space Lab program?
CSCP.
This mission is significant. It's one of the last of the Space Lab series that we've been flying, since STS-9 flew the first Space Lab mission, back in 1983 or so. So this has been a long series of Space Lab flights, and it's taken us really from doing experiments in a small Apollo capsule on the shuttle. It has allowed us to make these giant transition to fly scientists and the scientist astronauts back in the Space Lab module, where we're able to perform pretty sophisticated experiments. And this is one of the last of that series as we move on to space station. So I think this mission will be viewed as, the end of the era of the shuttle as our main base for doing experiments and research in space, and opening the door for the future for the International Space Station that's coming up. And in the International Space Station, we'll be doing operations up there, 365 days a year, 24-hour-day operations up there with astronauts. So the experiments that we're doing today in 16 days, we'll just be able to do more of that and expand our research and hopefully, develop new products, new processes, new pharmaceutical drugs that will all help improve life down here on Earth.
OTC DPS.
ODPS.
536 complete.
Copy.
And Don Thomas, Mission Specialist number 3, serving as the flight engineer on this mission, sitting in the aft center seat.
222, TLS on 21.
Go DLS.
So we treated implementation of SAP 92, that's steps 468 through 465, all steps performed.
Copy all, thank you. Astro TCR to ground 1.
Go ahead.
When you're ready, I would go to perform the post-ingress switch reconfiguration and switch guard removal per your checklist.
Roger, I'll advise you.
PC 516.
Copy.
CCLTC, did we get MS3 on board?
Not yet. Copy.
CDR, this is OTC. I have you loud and clear. Good morning, Jim, and welcome aboard.
Morning to you, Jackie. NTD, CDR, contact.
CDR, NTD, good morning. You're loud and clear, Jim.
John, you're loud and clear also, thank you. Houston, Columbia, contact on the CDR.
CDR, Houston, Jim, you're loud and clear. Good morning.
Morning, Don, thank you.
OTC, GLS on 2-1.
Go GLS.
Yes, sir, we'd like to have a go on step 538 is the GLS initialization.
I copy. You can pick it up per the clock.
Yes, sir, and we will need a CMTC on channel 162, and I do need to reach step 539 to you.
Ready to copy. Go ahead.
Okay, thank you so much. Step dual interrupt notification will be activated momentarily and may cause initiation of error messages at some consoles for interrupt monitor parameters currently out of GLS limits.
We copy. CMTCD copy 162.
And we can also give you a step 540 at this time.
Take 540 also.
OTC, PLT,
PLT, this is OTC. I have you loud and clear. Good morning, Susan. Welcome aboard.
Good morning, Jim. Thanks.
Come back, QC.
OTC, CBSE, 212.
Go ahead.
Step 555, biomed will be a not performed.
Copy, sir.
NTD, PLT, contact.
PLT, entity loud and clear. Good morning, Susan.
Mission Specialist Janice Voss now being assisted with her flight suit. She's MS number 1 and will be the payload commander on this flight. Some of the most essential experiments on this mission involve combustion in space. Janice Voss was asked to discuss what the objectives of space combustion science experiments are.
The combustion experiments are really basic research. As you can imagine, burning things in the environment of a space shuttle makes a lot of people, including the crew, very nervous. So it took a lot of development work to get experiments that were both safe and automated enough to run a large volume of experiments in a short bit of time and also would do good science. So they've been working to get these rack-sized combustion experiments on the shuttle for many, many years. And I feel very fortunate to be on the first flight where they finally got this all together. And we're going to be looking at some very basic science on how things burn. As you could imagine, a sphere is a very easy thing to mathematically model. And a sphere is what a flame looks like in space. That'll be very important understanding, for example, lean mixtures, how to make lean engines that'll burn very cleanly, fewer pollutants, more efficiently, mostly fewer pollutants. Burning in aircraft engines, how to make them more fuel efficient per mile. Burning in your home for heating your house in the wintertime. All those different areas can be optimized if we understand more details about the basics of combustion processes. And we have 2 rack-size experiments that are brand new on this flight. So we're going to be seeing some stuff that has never been seen before. And that's going to be very exciting. I'm looking forward to seeing those very first few burns of these brand new experiments.
545 complete.
Copy.
OTC asked, the CDR PLT ingress is complete. I'm getting ready to go on the post-ingress switch reconfig.
I copy S.
And OTC, the post-ingress switch reconfig is complete.
Copy S, thank you. CISL, do you copy?
No copy.
And ask OTC, when you're ready, you can pick up on the caution warning volume adjust.
Roger that, and confirm I'll be using parameter 99?
Affirmative, 99.
Roger. And OTC asked, BICOM volume adjust is complete.
Copy. OTC or VCC? Go. MS1 is in at this time. I copy 1638 GMC.
OTC, CSC1.
Station calling repeat.
CSC.
Go ahead.
Steps 531. 1 to 534 complete.
Copy.
Payload specialist Roger Crouch now preparing to enter Columbia. There are 2 payload specialists on STS-83, and he is one of those, and he was asked about why he was chosen and about why having a payload specialist on STS-83 is important.
As a payload specialist, Gregory and Linteris and I were chosen by the scientists who have experiments on board because they trust us to be representative of doing the kind of work up there that they want and having a background that will allow us to make observations and to carry out experiments that a less trained scientific eye may not notice or may not report at the right time. We're also concentrating on the scientific experiments, and then Janice, Voss, and Don Thomas, who are also scientists, by the way, will be more involved with training on the systems support for the space station, the operation of the space station, the maintenance of the hardware if there's problems there. They'll be carrying out scientific experiments also, but their primary responsibility is the maintenance of the space lab. So Greg and I are primarily responsible for the science. Don and Janice are primarily responsible for the systems, and then each of us are fully trained to carry out the scientific experiments. But then if the questions go into scientific interpretation, Greg and I are a little better versed in some of the background of that type of analysis.
RSRT OTC, air to ground 1.
Roger Crouch will be sitting in the mid-deck center seat. Greg Linteris will be to his right, and Mission Specialist number 3, Mike Gernhardt, will be to his left.
CMQC 556 complete, T-by 3339.
Copy.
This is shuttle launch control at T-minus 1 hour, 53 minutes, 57 seconds, and counting. The solid rocket booster recovery ships, Liberty and Freedom, are approaching their terminal support point in the Atlantic Ocean, and they are performing a radar and visual search of the impact area to assure that it is clear of ships, and will be relaying sea conditions and weather reports back to the shuttle weather officer. Their current position is about 125 nautical miles east of the Cape Canaveral Lighthouse.
OTC, GNC.
OGNC.
Yeah, P-pause is complete and that's been started.
Copy. Is there a coincident step?
One was step 560 and the other one was step 537.
Okay. Copy that, silent call. Thanks.
And we'll be picking up with 570 on your go.
Stand by, we'll verify the flight. GNC OTC flights ready for pre-flight align.
Copy. Look up for the clock.
Copy.
At this point in the countdown, we're standing by for the alignment of the inertial measurement units, part of the guidance and navigation system on board Columbia.
You loud and clear. Welcome aboard, Greg.
Afternoon, Jim. NTD, PS2, contact.
PS2, NTD, loud and clear, welcome aboard.
Thanks, John. Good to be here. Houston, PS2 ComSec.
PS2 Houston, you're loud and clear. Good morning, Greg.
Morning or afternoon, whatever it is, Bob.
This is shuttle launch control at T-minus 1 hour, 47 minutes, 50 seconds and counting. The solid rocket booster retrieval ships are nearing their on-station position. They left Port Canaveral at about 1 p.m. yesterday afternoon. They carry enough food and water to last up to 30 days if necessary. They have berths for up to 24 members. And they can cruise at a speed up to 27 knots depending on the weather and have a range of about 7,000 nautical miles. After the boosters are jettisoned from Space Shuttle Columbia about 2 minutes into flight at an altitude of 30 miles, they will continue upward for about another 70 seconds to an altitude of about 42 miles before they begin free fall toward the Atlantic Ocean below. At about 3 miles in altitude, a drogue parachute will deploy to slow the fall to the water, and about a mile above the surface, the main chutes deploy, creating a more gradual fall. The total descent takes about 7 minutes from the time they're jettisoned from Columbia, and they impact the water at a speed of about 60 miles an hour, usually about 7 miles apart. Usually the booster retrieval ships will station themselves about 7.5 miles from the predicted point of impact. Mission Specialist Mike Gernhardt now being assisted to prepare for his entry into Columbia. Mike Gernhardt has numerous responsibilities on STS-83, and he was asked to give some specific examples of what his role entails during the MSL-1 flight.
Well, on this flight, I'm the flight engineer for the ascent and entry. Basically, that involves working as a team with the commander and the pilot to address any number of different malfunctions that might occur and maximize the capability of the shuttle to regain redundancy and to achieve its orbit and so forth. As I mentioned before, we're doing 24 hours a day of science, and so there's a red shift, which will have the commander and the pilot on it, and they keep them together in case we should have to deorbit. They want them on the same sleep cycle. And then there's a blue shift, and I will be the orbiter lead for the blue shift. So I'll be responsible for keeping the space shuttle working and flying safely for 12 hours a day. And that involves a number of things like maneuvering the shuttle to align the inertial measurement units with stars to keep our navigation state current. There's any number of different housekeeping tasks. We have to do water dumps to keep our both supply and wastewater tanks at their nominal ranges. And then I also have to be prepared for any number of different malfunctions to occur. As we all know, the shuttle is very reliable and we have not had any serious problems to date. However, we're trained to deal with that, and so a good part of my time in training has been to address those, very critical off-nominal situations. I'll be prepared to do that, even though the chances are I won't be called on to do so.
OTC MS3, contact.
MS3, this is OTC. I have you loud and clear. Good afternoon, Don.
Good afternoon, Jim.
TVFS, OTC, 232, please.
OTC MS3, contact.
MS3, this is OTC. I have you loud and clear.
Loud and clear also, thanks, Jim.
OTC, OVCC. Yes, sir, go ahead. PS1, going in at this time. Copy. CQC 1658 GMT.
CD MS3, contact.
MS3, entity, you're loud and clear. Don, how many?
Loud and clear also, good morning.
Good morning to yourself and welcome aboard.
Good, Roger. Thanks, it's great to be here today.
OTC, OVCC?
No, sir.
MS2 in at this time. Okay, MS2 in 1659.
Houston, MS3, contact.
MS3, Houston, you're loud and clear. Good day, Don.
Good morning, Dom.
OTC PS3 MS4 will be NA and 535 is complete.
Please.
All systems, this is OTC. Verify you're ready for crew module closeout. OTC 574 complete. Ask OTC here to ground 1.
Go ahead.
We go to close out the crew module for flight and your checklist. Inspect for non-flight items and remove any additional items if found.
Okay, we're finishing up the crew here, but as soon as I do that, I'll get started on that.
Okay. And I have an open step on the PTOV camera that will need to work when you're ready.
Okay, I can do that now.
Okay, I think we left off on panel R14. You had verified the TV circuit breaker was closed. Is that correct?
I have verified that.
Okay, on R12, the TAC recorder, power on and mode record, is that verified?
Yes, I verified that just prior to crew ingress, as a matter of fact, and the switch is taped.
Copy. Thank you.
Roger.
C5 28, 29, 30 complete. Ask OTC here to ground 1.
Go ahead.
We go to close out the crew module for flight and your checklist. Inspect for non-flight items and remove any additional items if found.
Okay, we're finishing up the crew here, but as soon as I do that, I'll get started on that.
Okay. And I have an open step on the PTOV camera that will need to work when you're ready.
Okay, I can do that now.
Okay, I think we left off on panel R14. You had verified the TV circuit breaker was closed. Is that correct?
I have verified that.
Okay, on R12, the TAC recorder, power on and mode record, is that verified?
Yes, I verified that just prior to crew ingress, as a matter of fact, and the switch is taped.
Copy. Thank you.
Roger.
C5 28, 29, 30 complete.
OTC, CSCP.
SCP.
Give you step 572. Fuel cell bridge is complete.
Copy, sir. stations OTC, a momentary loss of downlist will occur. TGNC OTC.
TGNC.
Verify you're ready for step 632, ready for DPC downlist dump. Downlist data will be lost for 2 to 3 seconds.
We're going that OTC.
Copy, 632, you go.
OTC, CGLS.
Go GLS.
Step 662, GLS initialization is complete.
Copy.
OTC seems to say.
So,
Yes, sir. Line item 279 is now line item 280, new constraint. Sequence 16, step 1027.
copy. Can you fax us up a new back page?
Will do.
OTC, MS1, contact.
MS1, this OTC, you're loud and clear. Good afternoon, Janice. Welcome aboard.
Good afternoon, Jim. Loud and clear.
This is shuttle launch control at T-minus 1 hour 30 minutes and counting.
606 complete.
And in just a few moments, we'll begin the communications checks with all of the flight crew members on board Columbia. A purge of Columbia's fuel cells is now in work. And our countdown continues to proceed smoothly toward a 2 p.m. launch today.
OTC asked.
Go ahead, ask.
Yeah, just be advised, MS1 is not getting a side tone on her headset, although everybody can hear her. We're going to swap out her HIU, and instead we're going to progress on with MS2 comp checks.
Copy.
OTC, MS1 contact.
MS1 OTC, I read you loud and clear.
Loud and clear here too, Jim. Thanks, and I'm doing fine now.
I copy, Janice.
NTD, MS1 contact.
MS1 entity, loud and clear, Janice. Good morning, welcome aboard.
Morning, John. Loud and clear here. Houston, MS1 contact.
MS1 Houston, you're loud and clear. Good afternoon, Janice.
Loud and clear, Tom. Ready to go.
UC 614 complete.
OTC, MS2, com check.
MS2, this is OTC. I'll have you loud and clear. Good afternoon, Mike. Welcome aboard.
Thanks, Jim.
MTD, MS2, contact.
MS2, NTD, good morning, or actually afternoon, Mike, and welcome aboard. Loud and clear. Thank you, John. I got you loud and clear.
Houston, MS2, contact.
MS2, Houston, you're loud with a bit of a squeal in the background. Good afternoon, Mike.
Okay, Dom, one more contact. Testing 1, 2, 3.
Mike, that's a whole lot better. That's loud and clear.
This is shuttle launch control at T-minus 1 hour, 23 minutes, 15 seconds, and counting. The shuttle test director has just given a go for the Eastern Range to begin the checks of their range safety command carrier system. And also the chamber pressures of the solid rocket boosters are being verified. This will be done by the solid rocket booster test conductor. He'll confirm those pressures coming from transducers on the system, which measure the pressure in the thrust chamber at the nozzle. This information is used to tell the computer when to separate the solid rocket boosters in flight. Meanwhile, all continuing to go well with the countdown, the flight crew aboard Space Shuttle Columbia, and the communications checks with the flight crew now underway. And a report now that the Eastern Range checks of the range safety command system are complete, and they are now beginning the whole fire checks. This allows range safety to hold the countdown essentially right up until launch should there be any range safety issue involved. At T-minus 1 hour, 21 minutes, 31 seconds and counting. This is shuttle launch control.
OTC, TS1, contract.
TS1, this is OTC. I have you loud and clear. Good afternoon, Roger, and welcome aboard.
Thank you, Jim. You're loud clear, too. Let's go fly, man.
We're ready.
NTD, PS1, contract.
TS1, entity, loud and clear. Good afternoon.
Good afternoon to you, John. Houston, PS1, contract.
PS1, Houston, you're loud and clear. Good afternoon, Roger.
Good afternoon to you, Don.
OTC seems to think. What seems to think?
Line item 280 closed.
Copy. What's our current open capacity, do you think?
Currently, we have line item 242 and 277.
Copy. ahead, OVCC. Yeah, I just want to notify you we're sending 2 crew members down to pick up some silent sticks out of the truck. They had a lot of bad ones in the NASA suit tech kit. A copy. CDR OTC. CDR OTC or ground 1.
Bill for the CDR.
CDR, verify each member of the flight crew is ready to proceed with the Astrocom checks.
Stand by.
Okay.
OTC, CDR, Columbia is ready for the LCC Astrocom check.
I copy CDR, all stations. Any conversation on OIS 212 air to ground 1 during Astrocom checks will be heard by crew. Channel should remain silent except for emergency calls. And flight crew, this OTC, during the Astrocom checks, adjust your appropriate volume control. Do not change audio panel switch configurations.
Copy.
And OTC asked if I could just slip in here. All the non-flight items have been removed from the crew module, and I'm ready to terminate comm.
I copy. Thank you, asked. And flight crew, this is OTC on air to ground 1. Copy.
CDR, loud and clear.
PLT, MS1.
MS2. MS3. CS1. CS2.
And I copy all loud and clear. I'll go to air to ground 2 next. Flight crew OTC on air to ground 2. How do you copy?
CDR, loud and clear.
PLT, MS1.
MS2. MS3. CS1. CS2.
I copy, and ICOM A will be next. And flight crew, this OTC on air to air. How do you copy?
CDR, loud and clear.
PLT, MS1.
MS2. MS3. CS1. CS2.
I copy all loud and clear. We can return to air-to-ground 1. Thank you.
Roger that.
And CDR, this OTC back on air-to-ground 1. Our com checks are complete.
Copy.
Columbia, Houston, CDR and PLT configured for air-to-ground 1, com check.
That's in work now. Columbia's configured.
Columbia, Houston for the CDR and pilot, com check on air-to-ground 1.
CDR loud clear.
PLT, loud and clear.
Columbia, Houston, you're loud and clear also configured for air-to-ground 2.
In work. Configured.
Columbia, Houston for the CDR and PLT, com check on air-to-ground 2.
CDR loud clear.
PLT, loud and clear.
Columbia, Houston, you're loud and clear also configure for air-to-air.
Columbia's ready.
Columbia, Houston for the CDR and PLT, com check on air-to-air.
CDR loud clear.
PLT, loud and clear.
Columbia, you're loud and clear also configure for the SIMO voice check.
Roger. Columbia's ready.
Columbia, Houston for the entire crew, how do you hear?
CDR loud clear.
PLT, MS1.
MS2. MS3. CS1. CS2.
Columbia, Houston, we read you all loud and clear. This completes the air-ground voice checks.
Roger that.
CMQC 576 through 605, all steps complete.
No TC, CMQC.
Oh.
Line item 242 closed.
Copy. OTC. VS is off the headset at this time. I copy.
LTC ECL.
Go ahead.
CMQC on 143, please.
Team 2CD, copy.
Copy.
OTC or VCC? Go VCC.
Yes, sir. We'd like your concurrence to close the hatch.
Okay, if you're ready, I'll give you a go.
Thank you.
Team 2C612 is complete. CMQC 649 complete. TTVD OTC, leeward vent doors 1 and 2 are open, is that correct?
That's correct.
Copy, 646 through H, not performed. QC not performed, 646, 67, and 648.
We copy.
TGMC OTC.
Go ahead.
Have you given me 661?
Yeah, we can verify that.
Copy.
This is shuttle launch control at T-minus 1 hour and counting. At this point in the countdown, the ground launch sequencer, which will control the countdown in the last 9 minutes, is completing its initialization, ready for operation. The louver doors in the vehicle assembly building are being closed as a precaution against any contingency. And the solid rocket booster retrieval ships are being directed to their terminal support point, the location where they will stand by during the launch until the solid rocket boosters impact the water. That location is 138.5 nautical miles east of the Cape Canaveral, east-northeast of the Cape Canaveral Lighthouse. All activities proceeding on schedule. We're not working any issues. Weather continues to be cooperative, at least at this point in time. At T-minus 59 minutes and counting, this is shuttle launch control.
Big check.
This is shuttle launch control at T-minus 56 minutes, 40 seconds and counting. We'll be looking now at some animation of the Microgravity Science Laboratory module in the payload bay, and here with us to narrate the animation is John Heckel, the STS-83 Mission Operations Engineer.
As we fly up to Columbia's payload bay, the Microgravity Science Laboratory can be seen just aft of center. Coming into view now is the cryo-FD flexible diode experiment. It's a heat pipe experiment. Now looking at the MSL-1 module, we can look at the interior. The side we're looking at now contains the combustion experiments, namely CM1, Combustion Module 1, and the droplet combustion experiment. Coming around, the boxes you see on the center of the floor are the center aisle stowage containers. And on the side of the module coming into view are the furnaces. The large isothermal furnace supplied by the Japanese Space Agency, and Tempest supplied by the Germans. Also, the express rack is on that side. Moving back now. The orbiter's EDO pallet comes into view. Here is an extra set of liquid oxygen and hydrogen tanks for the orbiter's fuel cells. And pulling away is an overall view of Columbia's payload bay.
Thank you, John. All of our countdown activities continue to go smoothly. The hatch is now closed, and we still anticipate an on-time launch at 2 p.m. Eastern Time. At T-minus 54 minutes, 23 seconds and counting, this is shuttle launch control.
CCSE and RCRT go to 232, please, for S-band high power.
CCSE copy.
RCRT copies. CCSE.
QC677.
This is shuttle launch control at T-minus 53 minutes, 14 seconds and counting. The shuttle training aircraft doing weather reconnaissance is now departing the shuttle landing facility. That's being flown by astronaut Ken Cockrell. All of the standard weather observations and forecasting normally performed before launch have been underway during the past 24 hours. That began yesterday with a series of balloon releases and the launch of an upper altitude sounding rocket. The rocket measures data between 65,000 feet and 370,000 feet and sends back parameters on temperature, wind speed, wind direction, wind shear, pressure, and density of the air. And then there are also 9 Raywinson balloons released which collect data on temperature, humidity, wind speed, and direction and pressure up to about 100,000 feet. And then the 6 gym spheres, which provide highly accurate information on upper-level winds, provide that data up to about 60,000 feet as they're tracked by radar. This data from the gym spheres allows the flight dynamics officer to select a proper computer program aboard Columbia that will allow the shuttle's onboard computers to respond properly to the wind conditions as it climbs through the lower atmosphere. At T-minus 51 minutes, 7 seconds and counting, this is shuttle launch control.
C-686 complete. CCME LTC. CCME? 686, channel 128, please. Copy that. CC-688 complete. GLS OTC.
Okay, let's go.
Step 729 by the clock, please.
Yes, sir. We are standing by. Thank you.
CDPS OTC.
OTC CDPS.
Perform 741 for the clock, please.
Copy.
This is shuttle launch control, T-minus 47 minutes, 23 seconds and counting. Shuttle weather officer Ed Priscillic has just completed briefing the shuttle launch director, Jim Harrington, and we are still not working any weather issues locally that would affect launch today. Also, the booster retrieval ships are sending in very favorable observations from downrange, as are the weather buoys, which are located at 20, 110, and 160 nautical miles downrange. So at this point, from standpoint for a launch here in Florida, we are go for launch, and overseas at Van Jewel, conditions are also reported acceptable, and the only thing we're awaiting further word on is Edwards Air Force Base for abort once around. So with the countdown proceeding smoothly, we still continue to move toward an on-time launch. T-minus 46 minutes, 16 seconds and counting. This is Shuttle Launch Control.
TC is back on 212. Copy.
OTC GPS can give you completion of 741 through 746.
Okay.
OTC GLS on 212.
GLS.
Yes, sir. GLS mainline activation is complete at step 729 through 735 and a not perform on 732.
Okay.
Yes.
This is shuttle launch control at T-minus 40 minutes and counting. Once Columbia lifts off today, the solid rocket boosters will stage 2 minutes 6 seconds into the flight. The computer command to shut off the 3 main engines will occur at 8 minutes 28 seconds into the flight. And there will then be an orbital maneuvering system burn at 42 minutes into flight. And Columbia will be in a 163 by 160 nautical mile high orbit. The pilot tracking station at KSC will track the shuttle for its first 6 minutes. The Bermuda tracking station will then track until launch plus 11 minutes, and then the tracking and data relay satellite system will provide coverage beginning at the 11-minute mark and for the duration of the mission. During the second minute of flight, there is also a NASA tracking station at Ponce de Leon Inlet, about 35 miles north of Cape Canaveral, which is the primary communications link during that second minute, because during about a 1 period, the signal at the Cape is essentially blocked by the highly reflective plume of the solid rocket boosters.
So long through the high cab pressure decay rate.
The TDRS East satellite on this mission is TDRS 4 and is stationed over the Atlantic Ocean east of Brazil. TDRS West is the TDRS 5 satellite and is stationed over the Pacific Ocean. There will also be coverage from the Indian Ocean region through the TDRS 3 spacecraft as necessary, which is the zone of exclusion, normally not accessible by either TDRS East or TDRS West. And as a matter of interest, the original TDRS 1 satellite launched on ST6 is still in limited operation and will serve as the TDRS East backup should that be necessary. Also available to support from the ground if called upon are a network of 8 ground stations, part of the Air Force network of craft tracking stations. The cabin vent checks are now underway aboard Columbia, and we're awaiting word that the Eastern Range has completed all of its tests of the range safety system. And we also have confirmation that the orbiter's S-band communication system is now in the high power mode. And that system can communicate either directly between the orbiter and the ground or through the tracking and data relay satellite system.
212.
Go GLS.
Yes, sir. Step 760 and 760.
At T-minus 36 minutes, 48 seconds, and counting, this is shuttle launch control.
Not performed. Other steps were performed and are complete.
Copy. Go ahead.
Line line item 277 has been deferred.
Copy. Is that clear all?
Clears all.
Copy. Thank you. CDR teaching. We go to performing the pass DFS transfer prep.
Copy, pass DFS transfer prep.
This is shuttle launch control at T-minus 30 minutes and counting. At this time of the countdown, the orbital maneuvering system gaseous nitrogen tanks are being pressurized for launch. Gaseous nitrogen is used to operate the valves that allow the hypergolic propellants to flow into the orbital maneuvering system engines during flight. We have a weather report from the solid rocket booster retrieval ships, which we can pass along. The air temperature on station, 74 degrees. Water temperature is also 74. The seas are 4 to 6 feet. Winds east southeasterly 8 to 10 knots. Visibility unlimited. And a cloud coverage of about 7/10 currently, with a band of cloudiness over that area.
Thank you.
All our activities continue to proceed smoothly toward on-time launch of Columbia at 2 o'clock. T-minus 29 minutes and counting. This is shuttle launch control.
Pressure report during our cabin leak check. The nose seal has come off, and what we need to do is put another nose seal back on that port. In order to do that, we have to move the probe, put the seal on, and then put the cap on. The question is whether we can do that in time before we lose all the pressure, before we drop it below the minimum amount of pressure required to do the leak check. All right, let's all go over to 232 and talk it. Okay. OTC, CCME?
Go ahead.
Okay, 769 to 771 complete.
Copy.
OTC, PD.
Go ahead.
I get a go on 795.
What step was that?
795, sequence 16.
Okay, you gotta go.
No TC, team 16.
OTCC, GLS on 212. Go ahead. Yes, ma'am. GLS limit change and dual notification for BRS complete. That's step 799. Copy.
OTC, PD. No. Pre-flight bike check. Verified. Copy. CDR OTC.
Go ahead.
We had a little problem pressurizing the crew module there. The probe that we use to pressurize through has a nose seal on it. We need to replace the nose seal. We're going to bump the crew module pressure up just a little bit and then try to do a quick swap on the nose seal and take the probe out.
Pressure may drop significantly that you may get another master alarm. If you do, advise me and we'll give you a go to reset.
This is shuttle launch control at T-minus 24 minutes, 41 seconds and counting. We'll look now at a brief tape of the Microgravity Science Laboratory being prepared for its launch, and here once again to describe the activities is Mission Operations Engineer John Heckel.
What we're looking at is one of the 10 experiment racks that make up the Microgravity Science Laboratory. This one happens to contain the mid-deck glove box experiments. Each rack is integrated and then hoisted onto the experiment floor. Once that's complete, we have all 10 racks up. We'll start with our experiment interface verification checks and making sure that all of the experiments check out properly, they function, and they all work well together. After the IVTs are complete, we'll pick up the entire rack and floor train with all the experiments as a single unit and move it over to the Space Lab module. The experiment racks are then rolled into the module and the aft end cone is installed. After more checks with the experiments and the module itself, here we have a crew member doing a fit check. The Microgravity Science Laboratory is lifted out of its test stand in the operations and checkout building and placed into the payload transportation canister. The canister is then taken to the orbiter processing facility here we have the Microgravity Science Laboratory being lowered into Columbia's Payload Bay. This occurred on January 24th. January 31st. Here's a shot of the Payload Bay without the Space Lab transfer tunnel installed. And here is a view of the transfer tunnel connecting the orbiter's crew module with the Space Lab module. It's about 19 feet long in length. On February 24th, Columbia's Payload Bay doors closed and the Microgravity Science Laboratory was ready for flight.
And once we go into the T-minus 20-minute built-in hold, we'll hear Payload Director Bobby Bruckner poll the Microgravity Science Laboratory team for a readiness of the module as well as all of our mid-deck experiments, that they are ready for launch today and for their operation on orbit. At T-minus 21 minutes 20 seconds and counting, this is shuttle launch control.
OTC, I'll go to proceed with the troubleshooting.
This is shuttle launch control at T-minus 20 minutes, 10 seconds and counting. We're standing by to go into the 10-minute built-in hold at T-minus 20 minutes. In 3, 2, 1, T-minus 20 minutes and holding. And in just a moment, we'll be hearing Payload Director Bobby Bruckner poll his payload team. Weather continuing to cooperate both at the Cape and at our overseas sites. Edwards is not necessary on this mission to commit to launch. Closeout crew has been cleared from the launch pad and the white room configured for launch. They are doing the final securing of the hatch.
This is the Payload Director on 133. At this time, I will conduct a poll on the readiness of the payload community to proceed. DPO.
DPOs go.
MFL Mission Management. We're go. MFL Space Lab representative. Yeah, Space Lab is go. Okay, thank you.
PD, this is DPO.
This is PD.
Yes, when we had the director's review before the countdown, you mentioned you might not want to do the poll at the T-minus 9-minute hold. Have you made a decision on that?
That's correct. At this time, we're not working anything, so we will not do the T-minus 9-minute poll, and I've also notified the flight manager to that status.
Thank you, sir.
And as we heard, the Microgravity Science Laboratory is ready for launch, so poll at T-minus 9 minutes will not be necessary. We'll go now to the Johnson Space Center in Houston for readiness check of mission control.
This is Mission Control Houston. All activities here in the flight control room have been proceeding smoothly toward an on-time liftoff of Columbia this afternoon. The ascent team of flight controllers have been on duty here since early this morning, watching as launch controllers in Florida have moved through the final hours of the countdown and assisting the launch control team when needed. One focus of attention, as is always the case through the morning, has been weather in Florida and at various landing sites that could be needed around the globe. Those weather conditions in Florida are near excellent for a landing of Columbia there if that were needed for a return to launch site abort. That abort would be used in the event of an engine failure early on after liftoff by Columbia, landing back at Kennedy Shuttle Landing Facility. Again, all weather conditions there are excellent and do not constrain a launch this afternoon. Other sites, transatlantic landing sites, are located in Morone, Spain, Ben Guerir, Morocco, and Banjul, the Gambia. The weather at Banjul is favorable for launch. That's the only one site is required for a liftoff. That would be used for in the event of an engine problem later on in Columbia's climb to orbit.
Master arm as we're pressurizing. I copy.
Overseeing operations here in Mission Control for Columbia's launch is Ascent Flight Director Linda Ham. Providing communications with the spacecraft during its climb to orbit will be Capcom astronaut Tom Gorey. At T-minus 20 minutes in holding, this Mission Control, Houston.
And we'll go now to the Marshall Space Flight Center in Huntsville, Alabama to check on the readiness of the Microgravity Science Laboratory Payload Operations Control Center.
This is Space Lab Mission Operations Control, Huntsville, at the T-minus 20 hold. Space Lab Control here in northern Alabama serves as the nerve center for the science activities on board the Space Shuttle Columbia. Our Payload Operations Director has recently polled the cadre members and the mission science team, and all positions are reporting that they are ready and excited for the start of this busy 16-day Microgravity Science Laboratory mission. Science team members here standing by, and they're also standing by at 3 remote sites: Tsukuba Space Center located in Japan, the University of Colorado in Boulder, and NASA's Lewis Research Center in Cleveland, Ohio. The science team members will maintain communications with the crew and monitor the many experiments on board the Space Lab module as NASA continues its scientific efforts in the microgravity environment. The majority of the many experiments planned for this mission fall into the area of combustion science and material science. The science activities will be kicked off later this afternoon once the Shuttle Columbia attains orbit and the crew activates the Space Lab module on board Columbia's payload bay. This is Space Lab Mission Operations Control in Huntsville.
And we have about 3.5 minutes remaining in this built-in hold.
Copy. Safety console today. Safety console. Copy. Step 801. Step 801. OTC, CGNC. OGNC. IOU pre-alignment is complete, ready for transition Ops 1, and we also return DU2 back to 12.
Copy 893. NCD copy.
NCD copies. Sensitive conducting a T-minus 20-minute briefing. Launch window opens date 1900 GMT. That's 1400 local time. Closes 2.5 hours later at 21:30. There are no COLAs for today. Launch attempt, recycle launch attempt is possible if recycle occurs. And launch cannot be accomplished within the following time, or if the following time is exceeded, the entity will call cutoff. Launch straight back. Engine start box time is 4 minutes and 47 seconds estimated. DLT at T-minus 5 minutes. Perform APU start upon command of OTC only.
DLT copies.
Copy, and CDR. The pad egress system is in nominal configuration, and evacuation helipad is number 2.
Copy number 2.
And control room launch team, please disable your telephone ringers at this time. Control room access will be restricted after resuming the count at T-minus 20 minutes until after launch or flight crew egress. All personnel non-active in terminal account should monitor OIS channel 217. After T-minus 20 minutes, all problems or trends that require a countdown clock hold will be reported to the entity on channel 212 together with recommendations. After T-minus 5 minutes, any hold, manual or GLS, should be accompanied by a description of the problem and recommendation. The countdown clock will continue until T-minus 31 seconds unless the recommendation to hold at the next milestone is necessary. At T-minus 9 minutes, when a go is given, it indicates that the reporting element is free of problems which could constrain a successful launch. If a hold command is requested and issued between T-minus 9 minutes and T-minus 31 seconds, the countdown clock will be restarted upon a successful resolution of the problem without a go survey made of all elements after 31 seconds. Only cutoff is available and will result in a recycle to T-minus 20 minutes. For a cutoff, the ProWords CGLS gift cutoff will be used, and the milestones are as listed in item 11. And STE, any comments for the crew?
This is STE. The only comment is since the reach check is not complete yet, the crew may expect to get some SM alerts when we go to T1.
And the crew copy.
Okay, and any comments for the briefing in general?
That's a negative.
Copy.
And we have about 45 seconds remaining in this built-in hold before we count down to the next 10-minute built-in hold at T-minus 9.
Yeah, your call. I'd like to apprise the crew of the System 2 water spray boiler APU ready to start talkback.
Okay, you have time now.
Okay, we're monitoring
Go ahead.
System 2 water spray boiler steam vent temp. We're currently 133 degrees. The heaters are working. We expect during load sharing of the fuel cells that we'll dip below 130 required, and APU number 2 will read Barber pole for start.
Standing by to pick up the count now in 3, 2, 1, T-minus 20 minutes and counting.
20 minutes and counting.
ST-895 is complete. And CGSS step 903 is yours.
And 903 is complete.
Transitioning now to the primary ascent software, the primary computer launch program, and the pilot will be configuring the backup flight system computer to match that configuration.
our path ops transition is complete. We're ready for BFS ops 1.
I copy GPS step 910. CDR OTC, clear past fault sum, spec 99 Pro, and take DSFS to ops 1 per your checklist.
Copy that. Clear the message on CRT 1 and complete DFS ops 1. OTC, CDR.
Go ahead.
Yeah, I just want to confirm we're doing the right thing. I'm going to do the BFS ops 1 procedure, and it is true that we have not yet done the path to BFS transfer.
OTC DPS, our past BFS transfer is complete.
CDR, did you copy?
Okay, CDR copies. I'll press on the BFS ops 1.
NTD CPFS. Go ahead, VFS. Yes, sir, we're ready for BFS uplight. Copy 928. Houston flight entity.
NTD Houston flight 212.
Step 929, we're ready for BFS pre-flight uplink load.
Okay, we'll put it in work.
And CDR
OTC, CDR, BFS ops 1 is complete.
Copy, sir. OTC, CL. Stand by just a moment. PLT, OTC, configure path BFS horizontal fit displays per your checklist.
And what?
And CDR, config contingency abort yaw steer per your checklist.
And where?
CL, go ahead. DCR, we're at the point once again we're ready to remove the probe and install the cap, and CDR will receive a master alarm and klaxon. Copy. CDR, you have to go to reset those as they occur.
Copy, thank you.
And we have confirmation that the primary launch program, computer program, Ops 1 is now configured, ready, and the NASA test director has asked Houston Flight to send their pre-flight uplink command to the orbiter's backup flight system. And these are sent from Houston via the Mila tracking station out to the shuttle.
Copy that. MTD, TP 212. Go ahead, TP. Yeah, we have CH-20 on 161. Copy, CH-20 entity. CH-20 entity air ground 1 second. Okay, 161, please. Copy.
NTD Houston Flight 212.
Go ahead, fly.
Step 930 VFS pre-flight uplink load is complete.
Copy, CVFS entity. VFS, copy, thank you. CWS OTC, give you a 939, configure ohms RCS cross suite for flight. CWS, copy.
OTC, PLT, horizontal stick config, complete.
Copy, PLT.
And OTC, CDR, the config, report yaw steers complete.
Copy, CDR. And PLT are going to perform the MPS helium reconfiguration.
Captain what?
EPD and CFCT adjust fuel cell loads between 250 and 290 amps, step 957.
EPD copy. FCT copy.
OTC, PLT, MPS helium reconfig complete.
Copy. See, that's 934.
OTC, CWS,
CWS.
steps 940 through 944 are complete. Ohms RCS cross valves configured for flight.
Copy, sir.
FCT ISL.
Go ahead, ISL.
Do we have a go to activate OEX recorders?
And I believe you do. Houston Flight, JRPS entity, activate OEX recorder, step 960.
NTD Houston Flight, it's in work.
JRPS copy. At OTC ISL, I'd like to NTC over on 145, please.
QC, copy.
Copy.
Space OTC, discontinue all non-mandatory LDD traffic for remainder of count. QC 970.
Copy.
And all personnel, countdown clock will hold at T-minus 9 minutes in 1 minute 30 seconds. NTD, this HTD. Go ahead, HTD. Yes, sir, we just want to make the test team aware that with doing cabin vent deflate, we've completed our autocals, that from T-minus counting on down, we will probably be violating our LTC requirements for O2 in all the areas. Understood, but we want to make y'all aware of that. Okay, copy that, CHD. SDNT.
Yeah, this is FT.
Did you copy HTD?
Yeah, I did. I guess we need them on 161 for a minute.
Okay. HTD, are you available to support 161 right now?
Yes, sir, that's perfect.
Okay, thank you.
And we're 30 seconds away now from entering the 10-minute built-in hold at T-minus 9.
CPROC entity 212. CPROC, go. Okay, 161 with HTD.
Okay, gotcha. Thanks.
NTD CVFS. Go ahead, CVFS. T-flight jumping spares complete, no misconfirmed. Copy, thank you, OTC.
Going into the built-in hold in 3, 2, 1, T-minus 9 minutes and holding.
NTD SRO 212.
Go ahead, SRO.
Yes, sir, the range request clearance for laser illumination to begin at L-9, T-9 through launch. We'll report completion.
Okay, SRO, we still have personnel on the pad, and we'll give you a go probably about 15 minutes from now.
Copy that.
OTC CL212.
Go ahead,
Okay, two things. One, the pad has arcade continuing on with op support setup 20, the side hatch closeout. And also crew module pressurization initial leak check is complete at step 736. And we pick up with 738 now.
Copy that, NTD, copy 736, 737. Copy, STM.
STM 737. Copy that.
CDR OTC.
Go ahead.
Form cabin then redundancy configuration.
Start somewhere. OTC CDR, the cabin net redundancy config is complete.
Copy, sir.
And OTC CL.
Go.
Okay, just to let you know, they're going to have to cancel pending because we're not going to be done in 10 minutes.
We understand that.
And we have about 8.5 minutes remaining in this built-in hold. We are behind clearing the white room of the closeout crew. So there is a possibility that we'll be extending this built-in hold.
Early at the T-minus 9-minute hold point in order to complete some activities within the pad.
Okay, we have canceled all pending resume requests.
CGO SXT, I copy, thank you. And ECL LTC, we're standing by for your cabin vent redundancy check and final cabin integrity check complete.
Yeah, copy.
CISL entity 212.
ISL.
So we're going to hold off on the opposite quarter activation as well, and I'll try to give you a heads up as soon as possible.
ISL copy.
So we will be extending the hold at T-minus 9 to allow time to have the white room fully clear the pad.
TC CL212.
Go.
Okay, so I can't send the redundancy check is complete.
Okay.
And for step 750, record negative 0.005.
Copy on 750.
And we're ready for 751.
Copy, CHD OTC.
OTC, OTC.
Go ahead, OVCC.
Yeah, we'd like your concurrence. Go ahead and start breaking the white room down.
My copy, sir, here we go.
And all the rest of the pad crew has cleared the pad. Only the white room crew remains, and they're getting that closeout now.
Go ahead.
Can I get a ANTD on T21?
Copy. Coming over.
OTC, OVCC.
Go.
Yeah, we'd like to know if we could get concurrence to go with one of our carrier panels that has 6 crews
to go with only 5 screws installed. And OVCC, this is entity, and the description being unable to install the 6th screw. That's a firm.
OTC, CL. Yeah, I need to pick up with 752.
Yeah, I understand that. CACD, OTC. OVCC, this is entity. We'll work on that request shortly. Copy. ST entity 212.
Go ahead.
Okay, if you copy the request, could you evaluate that and let us know?
Could you repeat that again, please?
Carrier panel on the crew hatch only has 5 screws holding it in. It normally uses 6. 6th screw will not go in. We like to get the cars to fly as is.
Stand by.
DHCD, are you on 212? OTC, this HCD, I'm on 212. HCD 751 is yours, ready for cabin vent. Air will be vented into orbiter payload bay and out.
Caught that, and I'll accept that. And I guess from what I understand, what we're going to do is TV is going to hold off going to low flow rate. We're going to stay at 230, and I guess we're going to extend the hold at T-9 until we get the O2 from this vent to the acceptable levels.
All right, we copy that. We'll get the specifics of what you just said in a moment. CDR OTC, ever go to open cabin vent ISO valves?
Okay, where?
And CDR, if you get a master alarm, you ever go to reset? OTC, OVCC. Stand by.
OTC, CDR, the cabin vent steps are complete.
Copy. ECL?
Yeah, ECL copies. You got 754 done.
Copy.
Entity ISL.
Go to ISL.
Yes, pre-line reaction quarter configuration complete. Copy.
And ECL 757, if you'll acknowledge, please.
Yeah, we acknowledge that.
Copy. QC 762 is complete. Copy.
OTC, OVCC?
Go OVCC.
Yeah, we got 6 good screws now.
Copy, sir. We'll stand down on your earlier request.
Copy.
Entity copy. And I copy as well. SD entity air to ground 1.
SD copy.
And OTC to HCD.
Sorry, CD.
At this time, I'll give you sequence 16, step 1013 on page 851.
I copy 1013.
NPDSD.
Go ahead, SD.
Okay, are you aware that we're going to have to hold for a little bit and get the GN2 and the O2 level in the mid-body back down to where they need to be? Now that we've been pretty late here.
And I copy that SD, and I'm aware of that. And I believe the estimated time you're thinking is approximately 8 minutes. Is that correct?
That's the firm. That's with 170 pounds of flow in the mid-body. We're at 230 now, and we're going to stay there, so that should quicken that up a little bit.
Okay, and the limit we're looking to get below in the aft
is 0 above background.
Let's copy that. And let's talk a minute about IPR 143.
143, I believe we're working to get that moved to MLP IPR and no constraint.
Okay.
OTC, TLT. Some of us would like to pressurize our suits momentarily.
You ever go?
Copy that.
OTC, sir. Yes, sir, go ahead. Flight room's done. We're getting ready to clear off the pad. I copy. We appreciate your help today. We know it's been a lot out of the ordinary. Okay, we're headed down to the truck. Okay, stand by on this channel for just a moment. Okay.
And word now that the White Room crew is leaving the White Room. They were delayed in clearing out in order to complete the cabin leak check because a seal had to be replaced associated with that leak check, and that seal's on the hatch. So that took some additional time to replace that seal and do the retest and secure the hatch. So we will be behind slightly in our launch time, perhaps a quarter of an hour or so, but we're still waiting final assessment on where we stand of being ready to pick up the countdown. We're extending the T-minus 9-minute built-in hold at this point.
Copy both. Safety console, excuse me. Safety console, pack console, entity, step 819. Safety copy. Pack copy. JFIR entity, 212.
Go ahead, GFR.
Step 821.
Copy, sir.
CPVD OTC, step 823 is yours.
Copy that. Good work.
STM entity, 822.
STM copy.
NTD FT. Short FT. Need fuel cells on 1613. Copy. CFCT entity. CFCT entity, air to ground 1. FCT. 161 with FTE, please. Copy.
LCC, please.
Go.
Then go into a normal first configuration.
Copy NTD 825. Copy 825.
We're at T-minus 9 minutes and holding. Again, this hold has been extended to allow the White Room crew to leave the pad. The final checks of the hatch, the leaks got behind because the seal associated with doing that test had to be replaced. And then there was some trouble getting the care plate back in over where that seal is installed. But there's really no problem. It's just a matter of having gotten behind in all of this activity because of that test problem. So we're probably 15 or 20 minutes down, and we're still pressing toward a launch as soon as we're ready to go. We really don't have any technical problems.
NTD SDE 212.
Go ahead, STE.
And pad staff on 161, please.
CHD entity. Go, please. 161. Copy. CBHY entity at ground 1. This is CBHY. Okay, I understand for IPR 143 all your troubleshooting activities are complete. Successful? That's correct, Janice. That has been transferred to GSV against mesh flow. Okay, copy that.
NTD for AT212.
Go ahead, Station.
So I'm in contact with the M113 crew. I see I'm still sitting there at camera 45.
And we've given them a heads up.
Copy.
OTC, CDR, the closed vent valve steps are complete. I copy, sir. NTD vent valves are closed. Connected. SRO entity 2. SRO. Step 954, the KSC area is clear for launch, and I'll give you a go to begin laser illumination at T-9 and counting.
Copy all, thank you.
T2.
Let us see.
969 verify is complete.
Okay. CDR OTC, I will go to trigger CRTs for ascent. Copy, thank you. UC91 complete.
OTC, seal. Oh, just for the record, our IPR 144 is not a constraint to launch. No field can we put in. It's the IPR will be upgraded and closed.
Copy, NTD, copy. I copy.
White room crew back now to the launch center area and the
Analysis entity on 212. I'm going to go ahead and perform the launch status check of all systems. We believe we're coming to a closure on the late count anomalies. And ISL's JRPS and Houston flight step 999 activate recorders. Set copy.
That's copy.
Okay, and this is the entity conducting launch status check. I'll step verify, ready to resume count, and go for launch. OT. OTC's go. Copy. TBC. Vectors is go for launch. PTC. PTC is go. LTS.
LTS is go.
Houston flight.
Houston flight is go.
Copy. Mila. Mila go. STM. STM go. Safety console. Safety console. STE.
SDE is no-go at this time.
Copy. STAR. Columbia is go. Copy. LRD. LRD is go. And SRO.
SRO is go. You have a range clear to launch.
Copy SRO and STE entity. I understand we're still working IPR 144 for closure. Is that correct?
That's correct. Not what's holding us up right now.
Okay, what is your concern at this time?
We're still worried about the mid-body levels and the animals, and I think the guys will be coming over shortly to give you a briefing on that.
Okay, copy, and that's all under the guise of Flight 144 IPO. NTD OTC, can you verify 996?
And the holdup is an evaluation of the
PVD OTC.
gaseous oxygen concentrations in the mid-body area. We're seeing some readings that are not trending the right direction, so that's under discussion. Meanwhile, Lauren Schreiber, chairman of the mission management team, is conducting his poll.
ISL. Go ahead. Altitude recorder activated. Copy.
MS2 OTC.
Mike, MS2, go ahead.
Go to perform PPOV camera switch action, panel 019, TV power switch on.
Okay, that's in work.
Yeah, SPC, that's ACD.
So 19 steps are complete.
Up to 2.
DCDPS.
Go.
Yeah, CD can reset the SR on the BFS machine.
CDRD copy.
That's in work. And complete.
Copy.
NOT CDPS.
Go.
CDR to reset the SR with the pass machine.
CDRD copy also.
CDR copies, and that is complete.
And NTD-ST.
What ST?
Yeah, working this concern about O2 in the mid-body. I guess what we've included is we like to move the purge to 170 pounds from 230 and then proceed.
Okay, ST, I understand based on your discussions on 161, what O2 level are we looking for in the payload bay and orbiter aft compartment?
Okay, we're going to be looking for any increase above background over the next 9 minutes. That background or the O2 level should be decreasing, so Havs is going to look for any increase to their trend.
Okay, I copy that. And SC,
this is SC head.
okay, and let's look at the LCCs. Have we altered any of our current CCs?
Yeah, and that's the next thing I talked about. Has 08 is the first one, and it goes with mid-body and payload purge. It says we need to be above background down to 31 seconds. Probably be above 0. We're at 250 and decreasing at this point. And like I said, cells and CPROP are concurring that that's okay. Again, we're going to look for any increase from what we have currently.
And ST, this ACD.
Go ahead.
Yeah, we're down below 50 in the payload bay, and we're getting ready to update the mid. I expect to be below 50 ppm on that. So probably by the time we go on, we'll be on where we wanted to start at the beginning.
Okay, and NTD, based on that, if we change purge to 170, we're clear to go, and we're no violation at all.
Okay, I copy that, ST. And we got your concurrence to implement decreasing the purge at this time, correct?
That's affirmed.
The OTC. A copy with your concurrence of PVD 993. And you have a go. PVD copy.
PVD copy.
CHD, entity, air ground 1.
NTD, this ACD.
And please report your current O2 readings, payload bay and orbiter aft.
Payload bay is 48, mid-body 63, and aft was 82. And they're still decreasing.
Okay, copy that. And ST, entity.
Here's ST.
Do you have any constraints, and are you ready? You go for launch.
No constraints, or clear to launch.
I copy that. Launch director entity. Go ahead. That's 143 and 144 have been resolved, and you heard the vehicle is safe and ready, and your launch team is to proceed.
Copy. To a pole at this time. Payload director.
Payload the go.
Copy that. Engineering director.
Ready to go.
Roger that. Safety and mission assurance.
SNMI is...
Copy that. Lane.
Launch director, no constraints to launch, over.
Copy that. And ops manager. Jim, the MMT has no other issues. You're clear to launch. Copy. And Columbia will be picking up momentarily. You guys have a great mission, and we'll see you back here in about 2 weeks. NTD, you're clear to launch.
Columbia copies.
Launch director NTD, I copy. And all personnel, again, will begin the countdown clock at T-minus 9 minutes and counting momentarily. CPOS entity.
Let's go.
You pick up the countdown clock on your mark.
I copy. 3, 2, 1, mark.
And we're now at T-minus 9 minutes counting.
Elevate flow rate is set for launch. That's step 996.
I copy.
CLS auto sequence has been initiated.
Ground launch sequencer now controlling. Between now and launch, over 1,000 parameters will be checked by the ground launch sequencer to assure that we're ready to hand off to Columbia's onboard computer. Next major event is retraction of the orbiter access arm. In about one.
TLT-OTC, configure fuel cell essential bus source switches.
And what? TC, TLT, the bus is connected to fuel cell.
Copy PLT.
Yeah. Okay, hold up.
T-minus 7 minutes, 30 seconds.
Let's go for orbiter access arm retract.
Next major milestone will be the pre-start procedure for the auxiliary power units at T-minus 6 minutes.
RPS OTC, start APU and hydraulic strip chart recorders.
The RPS copies and work.
TLT OTC, I would go to perform APU pre-start.
That's in work.
That's the RPS strip charts running.
Copy.
Next major event will be starting the flight recorders at T-minus 5 minutes, 30 seconds.
2 gray top batch. APU 2, bobber pole.
Copy PLT.
Standing by to start the auxiliary power units at T-minus 5 minutes.
PLS is go for orbiter, AT start.
AT start.
TLT, have a go to perform A start.
TLT.
And we're now activating the firing chain to the solid rocket boosters and the external tank range safety system.
You have a go to reconfigure heaters.
Roger.
Starting the liquid oxygen drain back procedure. Terminating liquid oxygen replenishment.
AT start complete. Press light off.
Copy.
Standing by to start the main helium purge sequence, preparing for main engine start activity.
PLS is go for purge sequence 4.
And now we'll be checking the flight controls on the orbiter, the aero surface profile test. Vehicle will get to internal power in about 10 seconds.
CDR OTC to verify heater configuration complete.
Yes, sir, it's complete. Thank you.
Copy.
Coming up on T-minus 3 minutes 23 seconds. We're now gimbaling 3 main engines, checking their steering capability. Next activity will be to pressurize the liquid oxygen tank on the external tank. T-minus 2 minutes 55 seconds. And we'll start the retraction of the Gox beanie.
Pressurization.
TLT OTC, have a go to clear caution warning memory and verify no unexpected errors.
Captain what?
Topping off of the fuel cells being terminated.
Caution and memory clear, non-expected errors.
And copy flight crew, be able to close and lock your visor, initiate O2 flow, and enjoy your on-orbit spring break.
Good ahead, sir. We'd like to say thanks to everybody who has got Columbia and Andy to fly. PLS is go. ET, LH2 pressurization.
Pressurizing the hydrogen tank on the external tank now. Replenishing the liquid hydrogen tank has been terminated.
T-minus 1 minute 30 seconds.
Standing by now to arm the sound suppression water system. T-minus 1 minute. All rocket booster joint heaters being turned off. Final check now of the booster fans. Locks and LH2 fill and drain valves are closed. Payload bay vent doors are positioned. Standing by to hand off to Columbia's computers.
PLS is go for sequence start.
And the handoff has occurred. Columbia's computers now controlling.
20.
Firing chain is armed. Sound suppression water system activated. Range safety systems armed.
10.
9, 8, 7. Ignition seek start. 5, 4, 3, 2, 1. And liftoff of Space Shuttle Columbia with the Microgravity Science Laboratory, our research bridge to the space benefits of tomorrow.
Open down, Houston.
Roger, roll, Columbia.
Houston's now controlling. Columbia is rolling on course toward a 160 nautical mile high orbit, inclined 8.5 degrees to Earth's center. Columbia already traveling 300 miles per hour. Columbia's three main engines is now throttled to 2/3 throttle to prepare the spacecraft to pass through the area of maximum air pressure and go supersonic. Altitude now 2.5 miles, 1.5 miles east of the launch pad. Columbia is traveling 650 miles per hour.
Columbia, go with throttle up.
Copy, go with throttle up.
Columbia's three main engines now back at full throttle. Systems on board in good shape. Columbia's speed now 1,500 miles per hour. Altitude 12 miles, 9 miles east of Kennedy Space Center. 4.5 minutes since liftoff, Columbia has already used more than 2.25 million pounds of propellant and weighs less than half of what it did at launch. One minute to 55 seconds since liftoff. Flight controller standing by in the next few seconds for burnout and jettison of the twin solid rockets. Booster off confirms good separation of the solid rockets.
The performance is nominal.
Performance nominal.
That call indicating that Columbia's performance thus far is just as planned. Altitude now 34 miles. Columbia is traveling 3,000 miles per hour, 42 miles east of the Kennedy Space Center.
Columbia, two-engine Banjul.
Copy, two-engine Banjul.
Call indicating that Columbia could reach a transatlantic landing if needed. All systems are continuing to operate well. Three engines at full throttle. Altitude now 45 miles. Columbia speed 3,100 miles per hour. 70 miles east Kennedy Space Center. Columbia speed now 4,300 miles per hour, altitude 58 miles. Columbia airborne now for 4 minutes.
Columbia, negative return.
Return.
Call indicating that Columbia has gained too much speed and too much altitude to return to the Kennedy Space Center in the event of an engine problem. All systems continuing to operate well in the spacecraft. Speed now 5,000 miles per hour. Over the next 4 minutes, Columbia will level off its trajectory, maintaining an altitude of around 60 to 70 miles, and more than tripling its current speed of 6,000 miles per hour to reach 17,400 miles per hour required for orbit. A minute since launch, 3.5 minutes to cut off of the main engines. Columbia now 235 miles east of the Kennedy Space Center, altitude 68 miles, speed now 7,500 miles per hour.
Columbia, press ATO.
Copy, press to ATO.
Call indicating that Columbia could reach a lower than planned but safe orbit if an engine were to fail. All systems continue to operate well.
Columbia, single engine ops 3, Joule.
Single engine, ops 3, band Joule.
Columbia, press to MECO.
Press to go.
Columbia speed now 9,200 miles per hour, altitude 70 miles. Columbia 360 miles east of the Kennedy Space Center.
Van Joule, 104.
Single engine, man, 104.
This call is indicating Columbia could reach a transatlantic landing on only one engine if required. All three engines operating well at full throttle. All systems in good shape on board. 6.5 minutes since launch, 2 minutes to cover the main engines. Columbia is now traveling 11,000 miles per hour, 465 miles east of the Kennedy Space Center, altitude 69 miles.
Columbia, single engine press, 104.
Single engine press, 104.
Call indicating that Columbia has gained enough speed to reach its planned orbit on only one engine if needed. Columbia speed now 13,000 miles per hour, 575 miles east of the Kennedy Space Center. 1 minute to cut off of the main engines. Columbia's engines are now beginning to throttle down to prevent the shuttle from experiencing forces in excess out of 3 times Earth's gravity. 30 seconds to cut off of the main engines. The speed now 15,500 miles per hour, 725 miles east of the Kennedy Space Center. About 10 seconds to cut off the main engines. Booster officer confirms cutoff of the main engine.
We showed a nominal MECO. OMS 1 is not required. You have a go for the photo DTO.
Copy, go for the go.
Booster also confirms a good jettison of the external fuel tank. The crew's also been given the go-ahead now to maneuver Columbia in position that allows crew members to photograph the jettisoned external fuel tank as it moves away from Columbia.
Houston will be using nominal OMS 2 targets.
Copy, nominal OMS 2 targets.
Columbia, Houston, for the thermal message on panel L1, Jim, we'd like to take the high-load duct heater to A/Bravo.
To A/.
Columbia, Houston, you have a go to load the targets.
Okay, copy, thank you.
Columbia, Houston, Sue, you have a go for APU hide shutdown.
Copy and work.
Houston, we're getting the camera put together right now. We'll be ready for the attitude maneuver momentarily.
We're ready for the maneuver when you are.
Okay, thank you.
This is Mission Control, Houston, Columbia's current altitudes. Columbia's current altitude about 80 miles. On board and in Mission Control, clocks are now counting down about 24 minutes from now, when Columbia will fire its orbital maneuvering system engines to circularize into an orbit with an altitude of 160 nautical miles, or approximately 184 statute miles.